when I'm summarizing this, I'm starting back at the beginning of the notes. You guys already have these notes. I'm going to summarize back from the beginning, and I'm just going to talk about each one and how did I know what to do on each one. So a question like this, it says, determine whether a linear binomial is a factor. That's where we started. So when we are determining whether something is a factor, remember what we're going to do is we are going to do synthetic division. We're going to work it out, and at the end, when we're done with the synthetic division, we're looking at the remainder. If the remainder is 0, then we go, oh, okay, that is a factor. If it's not 0, then it's not a factor. But this is because they're saying determine whether it's a factor. So instructions on this one would not tell you to factor. It would say determine whether it's a factor. So that's like the one that's kind of different from these. These are actually the easier to recognize. And again, these should be in your notes. This is the one where you wrote down the coefficients, 1, 2, -3. Out here you had a 3 because it's the opposite of this number. And then you brought down and you did 3 and you did 5. And then 3 times 5 is 15. So the remainder was 12. So this one was not a factor. So that's how we did those types of problems. I'm not going to go through like how to do each one because we have 2 new things we still have to learn today. And I'm trying to at least be cool about like how do we do them. So now this, for a question like this, it will not say factor out the GCF. It will not tell you that. So the question is, how do I know to factor out the GCF? So when I look at this, what is a good sign? Like, what is something that I notice that might tell me that that is a GCF type problem? I'll tell you this, I'm looking at these 3 things and making a determination.
All the numbers could be divided by
They all have something in common. Every single number has something in common. If they have something in common, I would always go for GCF first. In this case, 2 goes into all of them and x squared goes into all of them, leaving us x squared minus 2x plus 4 factored, done. Because all of them have something in common. I see it. I go, oh, okay. It's not like they're square numbers. 2 isn't a square number. 8 isn't a square number. And then I look at it and I go, oh, okay, well, the best that I can do here is that they all have something in common. So I pulled out that common factor. That's what we did on day 1. That was the first day of this.
So there's a number that's not squared. It's like factoring out to the GCF. That's what it is.
Well, I've just noticed that anytime, I'll tell you, I always go for GCF every single time that I see that they have something in common. They at least have a 2 in common, so I know I can factor that out. Okay. Let's see what's next. Then we got to factoring these that had the leading coefficient of 1. So that's when we tried these. We were like, okay, well, this is where the leading coefficient was 1. These are the ones that kind of worked out nicely. We're looking for 2 numbers that multiplied to make 6, that added to make -1. So what were the 2 things that multiplied to make -6 that add to make -1? -3 and +2. And that's how we did this entire section here. If it doesn't work out, if there is no combination, we call that what? Prime. Okay, so this is what we did on day 2. Now, the hard part about the second part of day 2 was we ran into problems like this. Now, one that works out was this one right here. So this one does have a leading coefficient of, actually, I don't want to do that one because we can factor that 2 different ways and there's an easier one. Let's do this one. This is one where I noticed that they, I guess, actually, these do have something in common. So one of the things that we could look at is, what I want to see is, let's go for this one. So notice that I have a square number in front and a square number at the end there. One of the things that we said is that when you have that situation, when there's a square at the beginning and a square at the end, we're going to find A and we're going to find B. And we do that by taking this is like we take the square root of this to find A. What is the square root of 4x squared? 2x. And what is the square root of 81 to find B?
9.
Is 9. Now, we had that formula, and the formula looks like this. This is what people are going to forget. I know that this is going to be the one that's going to like tear up people's grades right here, is because it's a squared plus 2ab plus b squared. There's another one that looks just like that. The only difference is that plus is swapped out. So if it works, if this, like I plug these in there and it works, then this will be the exact same thing as a plus b times a plus b, which is a plus b squared, bless you. So check it out. I'm just going to do this real quick. I'm going to plug these two things into that equation right there. So I've got 2x, and it needs to be squared, plus 2 times a, which is 2x, times b, which is 9, plus b squared. If these end up as the same thing, then I can use this method. So this becomes 4x squared. This becomes 36x when I multiply that out, and this becomes 81. These are, in fact, the same thing. Therefore, all I need to do is write the answer just like this and plug in a and b. What is a? What is b? Now, these are the same things that are in your notes. I'm not writing anything new. These are the same things we did on those. If you went back to the video, we already did these. Exact same problems, already worked through them. That's when we saw squares at the beginning and squares at the end. Then we got to yesterday, and we did the difference of two squares. The difference of two squares, the first thing was a square, the second thing was a square, and it was subtraction in between, which it ended up as two things, a plus and a minus. A plus and a minus. Each of them gets an a, and we take the square root of this. That's 3 and 3. That's all there was for that. That was the easy one.
That was the only thing. That's how all of them were.
Yeah, all of these were like even, like look, we had this one here. Come on. We had this one here. It breaks down into two things. That's the difference of two squares. This would be x and x, a plus and a minus, 11 and 11, done. I think those are the nicest ones. Like, they always work out nicely. After today, you'll be able to do everything on the homework. Okay, then we did 4 terms. We have 4 terms. Well, we did those by grouping. And when we did them by grouping, it looked like this. Okay, I'm having some issues here. There we go. We grouped them. So we wrote x to the third plus 3x squared, and then we wrote negative 4x minus 12. We grouped them together, and we pulled out the greatest common factor. So the greatest common factor there would be what? X to the second power, leaving x and 3. We go to the other one. We pulled out the greatest common factor, and the greatest common factor was negative 4, leaving x plus 3. At this point, why do I think this is good? Because these two things match each other, which means that x plus 3 is one of my factors. That's what we did yesterday. And the other factor is x squared minus 4, which came from right there. But am I done? No. What do I still need to do? The difference of two squares. That x squared minus 4 is x plus 2 and x minus 2. And then we still have an x plus 3. That was that one. And that takes us all the way through yesterday. So that's this whole week's lesson up to today. Now...
The bottom part would have been to the x plus 2, plus 2.
Sorry?
The x plus 2, x minus 2.
Yep, that's the final answer. Yep. Okay, here is where things get a little bit interesting. So we're going to get into some things. Let me see. Okay, so now I am on next one. No, it's back here. This is the 4th slide that looks just like this. Factoring when a does not equal 1. When the number out front does not equal 1, they don't have anything in common. Look, they don't have any numbers I can pull out. Like, they're not squares. Like, it doesn't seem to match any of the rules. So, this one is not terribly difficult, but it does require an extra step. So, here's what we're going to do. I do not, please do not do this. I am not looking for two numbers that multiply to make 12, that add up to make 11. Don't do that. It's not that. So I've gone through and I've checked and it doesn't match any of those other things. The very first thing I'm going to do is multiply the first number times the last number. We call that A and C. That's the leading number and the last number, A and C. So we're going to multiply them together. What is 2 times 12? 24. Okay, this is going to sound a lot alike from what I did before, but do not rush forward because you're going to see that it's a little bit different. I need two numbers that multiply to make 24 that when added will make 11. Okay, so let's see. Positive 8 and positive 3, when multiplied, will make 24, and when added, will make 11. Do not write x plus 8, x minus 3. That is not what we're going to do. This middle term, the one that's in the middle, notice that it's 11x. I'm going to rewrite 11x as 8x plus 3x. Would you agree that if I said I have $11 or that I said I had 8 plus $3, they're exactly the same thing? So 11x is the exact same thing as 8x plus 3x. That's all I did was break it up. We're going to make this into a grouping problem. We're going to change this into a grouping problem, and then we can deal with it. All I did was change the middle term. So far, so good? Okay. We're going to do a bunch of these. So these are the ones that take some time. So here's what I'm going to do is now I'm going to group them. What do 2x squared and 8x both have in common? 2x. I pull out a 2x, and what's left inside? X plus 4. I'm going to do the same thing for the other one. What do 3x and 12 have in common? 3, a positive 3. After I pull out that 3, what will I have left inside? Notice anything familiar about this?
Yes.
Yeah, we're back to yesterday. Once you do that, you're back to yesterday. And we go, oh, there's one of the factors, x plus 4. And the other factor is what? 2x plus 3. I'll leave that up there for a second. We're going to do more of these, don't worry. All right, let's move on to B. Okay, notice that leading coefficient, that number right up front, is not 1, and these are not square numbers at the beginning and the end, and they have nothing in common. So I'm going to go, okay, well, this is that last situation where I'm going to multiply the first and the last together. What is 8 times 5? 40. So I'm looking for two numbers that multiply to make 40 that add to give me negative 14. Negative 10 and what? And negative 4. So negative 10 times negative 4 is 40, and negative 10 plus negative 4 is negative 14. So here's the part people forget. I'm going to take that 14, that middle term, and I'm going to split it up into a negative 10x and a negative 4x, because that's exactly the same as 14. That's no different. There's the 8, still the same. There's the 5x, still the same. Now that I have 4 terms, what am I going to do with them? Group them. All right. So we get 5x squared minus 10x minus 4x plus 8. Let's talk about what the first one has in common. Okay, so 5x, and what's left inside afterwards? X minus 2. What do the second terms have in common? Negative 4. After I pull out the negative 4, what will I have left? Are we feeling good about this one? Okay, I feel good about it too. So one of the terms is definitely x minus 2. What's the other term? 5x minus 4. Factored. That's a great question. He said, what if I had written it differently? Now, you do not have to write down what I'm about to do here, because what I'm going to do is just another way, and I don't want it to confuse anyone. If you don't understand what I'm doing here, don't worry. This part is just like a what-if question. He said, let's say that I was on the first step, and I had 5x squared minus 14x plus 8. What if I had written it like this, negative 4 and negative 10, like that way? It still works. Like he goes, so he's going to go 5x squared. He's going to break this down into negative 4x and negative 10x. He just reversed the 2 plus 8. It still works, and let's see what happens with the grouping now. So we've got 5x squared minus 4x. That's grouped together. And then negative 10x plus 8. Let's look at these first two. What do they have in common? X. And what would be left inside? And the second one, what would I pull out of those two?
-2.
What would be left inside?
5x -4.
Notice that they both have the same things. So right there, one of my factors is 5x minus 4, which is the same as the red one. And what's the other factor? X minus 2. Let's compare that to the original. Same thing. Yeah. So just because I like to show people, I don't want them to just believe things. All right. Somebody hook me up with this one now. I've done 2. You guys can do 2. All right, take it.
Alright, so multiply 6 times 5, which is 30. And then you have to find two numbers that multiply 30 by adding 17. That would add just 15 and 2. And then with 17x, that's 15x and 2x. And then I equals, and then I put 6x squared plus 15x in parentheses. And then I put plus 2, and then I put 2x plus 5.
Okay. Grouped them.
Pulled out from 6x squared plus 15x was 3x.
Okay, the greatest common factor is 3x.
And now we make it 2x plus 5. And then since I noticed that the other one was 2x plus 5, the other thing I could pull out was 1 out of that. And then it would make us 2x plus 5. And then we know that 2x plus 5 is a factor, so 2x plus 5, and then the remaining thing is just 3x plus 1.
Any questions about what just happened there? Here is the only 2 areas that I think people will make mistakes on here. Number 1 is forgetting that the numbers have to multiply on the outside, 6 times 5. Secondly is this, taking it, and now that you know those 2 numbers, split that 17x up into those 2 numbers, a 15x and a 2x. Don't drop the x. People lose those x's there. It's not just 15 and 2, it's 15x and 2x. We're splitting up that middle term. Now, this one could be done as like our squares. Notice the first one is a square one, and the last one is a square one, right? 4 is 2 squared, and 9x squared is just 3x times 3x. However, let's try it with this new method to just see how it works. Somebody different, help me out. Go ahead.
So you multiply the two other numbers, 9 times 4.
Okay, the first and the last number.
Yeah. And that gives you 36. And then you have to find two of the numbers that multiply to get 36 and add to get -15. And that's -12 and -3.
Negative 12 times negative 3 is positive 36, and when I add those 2 things together, I get negative 15, so those are definitely my numbers.
And then you bring down 9x squared minus 12x minus 3x plus 4.
These 2 numbers came from right here.
And then you put 9x squared minus 12x into a parentheses. And you put -3x plus 4 into a parentheses. And you take out 3x from 9x squared minus 12, and then you get 3x minus 4.
Oh, thanks,
And
man.
then you take out a -1 from -3x plus 4, and you get 3x minus 4. And 3x minus 4 is one of your factors, and the other is 3x minus 1.
You don't have to highlight it every time like this. I just find the reason that I highlight it like that is because a lot of times people don't get where I'm getting that from. And the other term comes from right there, 3x minus 1. Give it. Okay, our last ones that we're going to do, this is the last type of factoring for this lesson, is called factoring the sum and difference of 2 cubes. So they can be sum or difference in this case, and the 2 things that we're going to be dealing with are cubes. Like something to the 3rd power. That's what we're going to be looking at here. Well, I look at A right away, and I see that I don't see 3rd powers there. Like, I don't know about you, that does not look like 3rd powers to me. But I do see something else that I'm like, oh, well, I know that I could at least do this. What's the at least I could do this part?
Take out a 5x.
They both have a 5x. Let's pull that out. Let's just see what would happen. They both have a 5x. What would be left inside there?
X to the third, and then 8.
And 8. Now, here's what I'm interested in. This scenario. Both x to the third and 8 are cubes. Here's how I know. X to the third is obviously a cube. But why is 8 a cube?
This is 2 times 2 times 2.
It's the same thing as 2 cubed. So I'm just going to do this just so we can see it. X to the third plus 2 cubed. Those are the exact same thing. 2 cubed is 8. So this part that is in there, in the gray, is the part that we're going to work on. How do we factor that today? So I'm going to come back to this. This is the first part of the problem. I'm going to come back to it. So here's how it works. When you've got either the sum or the difference of 2 cubes, like we do right now, that's the part that we're dealing with. We use something that I call the SOAP method, S-O-A-P. So this is something I call the SOAP method. Okay, so this is what SOAP stands for. I'll explain it in just a minute. Same sign. Opposite sign. Always a plus. So same sign, opposite sign, always a plus. That's what SOAP stands for. And I'll show you how we're going to use this in just a moment. Now you can only use this when you have the sum or difference of 2 cubes, which we do, which we're going to deal with in just a second. I'm going to let everybody write that down. So check it out. There's only 2 scenarios that we're going to run into. One where we've got a cube plus a cube, or a cube minus a cube. And the way that this is going to factor is, we need to figure out what A is, and we need to figure out what B is. Once we do that, that is the biggest thing. So we're looking at just that gray area here for a moment. I'm going to move it over here for just a second so we can look at it separately. We're just going to go, okay, x to the third power plus 2 to the third power. We need to find A. What is being multiplied by itself 3 times to get me x to the third power? That would be x. X is the thing that's being multiplied by itself 3 times to get me to x to the third power. What is being multiplied by itself 3 times to turn into 8? 2. So my A is x, and my B is 2, which is a huge, important piece of information, and I'm almost done with this problem already. So, notice that this had a plus in it. That was important, because there was something with the plus and something with the minus. There was one for a plus and one with the minus, and here's how it works. I'm going to set up a binomial, 2 things, and then a trinomial, 3 things, every single time. And here's where the SOAP comes in. Same sign. I want the same sign as this, plus. I want the opposite sign of this. What's the opposite of plus? And then the last one is always a plus. So notice how at the bottom there, I saw the plus up top, so I went plus, minus, plus. That's because it was the same sign, then the opposite sign, and then always a plus. Now, if you look back up here, it says that the way that you factor these is you write A, B, A squared, B squared, and then just A times B in the middle. So I'm going to put A right here. What's A? I'm going to put B right here. What's B? I'm going to put A squared right there. What's A squared? I'm going to put B squared right there. What's B squared? What is 2 squared?
4.
Okay. And then finally, this one is A times, so this was B squared. Oh, B squared. This was A squared. This was A and B. What is A times B?
2 at the same time.
2 times x, which is 2x. That is the factored form of what we just saw right there. If we were to look at this, but remember, the one thing that's missing is, the one thing that's missing here is that all of this had a 5x out front. We have to remember that there was a 5x out front. We pulled that 5x out there. It's still there. We don't just get to throw it away. All right, let's do B. Notice that this is the difference, the subtraction of 2 cubes. Why is this the difference of 2 cubes?
There's a minus right there.
Okay, well, it's difference, but why is 8y cubed a cube? What times itself 3 times would give me 8y cubed? 2y. So this is the same thing as 2y cubed. Same exact thing. Minus, and why is 27 a cube?
This is
3 times 3 times 3, so that's 3 cubed. It takes a minute to be able to notice these sometimes to go, well, when I see something cubed, I get very suspicious. I go, I was hoping somebody would be like, don't be suspicious. All right, no TikTokers in here? So we got 2y cubed minus 3 cubed. Those are both things being cubed. So in this case, A is equal to what? 2y. And B is equal to 3. All right, good. That's a key piece of information. Every single time, this will break out into a binomial and a trinomial. 2 things and then 3 things. But how do I know whether they're pluses or minuses in there? So, same sign, opposite sign, always a plus. What's the first sign I'm going to write? Subtraction, because it's the same as this. So, same sign right there. What comes next? Addition, because addition is the opposite sign. And then the last one will always be a plus. Okay, so now here's how this looks. Remember, it's going to look like this. It's going to look like A and B, A squared and B squared, and then it's going to be A, B in the middle, just in case you forget. So, what is A and B? A squared, 4y squared, B squared. And then what is A times B? That is the factored form of by cubed minus 27. Nothing in this case because we didn't pull out anything. Remember, on this one we pulled out a common factor. We didn't have a common factor here. So in this one, that was a great question. This one we had a 5x because we pulled it out front. We couldn't just throw that away. All right. Interesting here. Doesn't necessarily look like 2 cubes at first. We might have to get a little clever here. But this is 2 cubes. It is the sum of 2 cubes. What are the 2 cubes? X squared cubed. Because remember, x squared times x squared times x squared, you add the exponents, 2 plus 2 plus 2 would be 6. Okay, it's not any harder, we just needed to identify them. What is A? What is B? It's going to break down into a binomial and a trinomial. What kind of signs do they have? A plus, a minus, and then always a plus. So I'm just looking to fill in these gaps now. What goes in the very first empty box there? A, which is? What goes in the second one? B, which is x squared. What goes in the first box of the trinomial? A squared, which is? What goes in the last box over there? Which is? X to the fourth. X squared times x squared is x to the fourth. So that's x to the fourth. And what goes in the middle one?
2x squared.
2x squared. That is the factored version of 8 plus x to the 6th power. Yes, ma'am?
Do you not put like a number in front of it, like the equation?
In front of, like, you mean out here? Like out here?
Yeah.
The only reason that the first one had them is because, remember, that's at the very beginning, these didn't look like cubes. But we recognized that there was a 5x that we could pull out that went to the front. So really what happened was this. Let's go back to this first one again, back to this step. There was a 5x, and then we're going to factor this right here. So we've got same sign, opposite sign, always a plus. What is A in this situation here? You can take some minutes. It's hidden off the screen, but what is A in this situation? A was X, and what was B? Okay, so now we've got A plus X, A squared, B squared, and then A times B. That's why this 5X was out front there. Because we pulled it out in the very beginning, whereas the others, we didn't have anything to pull out.
So B, you didn't put any number out.
Right. Now, I'm so glad. Will you take D for me? Because actually D is going to have something that's going to pull out to the front. So why don't you do D for me?
So
Start with what they have, because those don't look like two cubes to me. They don't. 2 doesn't look like a cube. 16 doesn't look like a cube. X to the 5th power doesn't look like a cube. X squared doesn't look like a cube. So let's talk about it. Let's see what we can pull out. GCF.
oh, okay, great contract.
Yep.
Which would be 2x2.
2x squared, which leaves me with what inside?
That would be x3, and then -8.
Perfect. Now, notice that what is in parentheses there does look like the difference of two cubes, right? So we've got 2x squared, x to the 3rd power minus, well, how can I write that as a cube?
Oh, 2/3.
2 to the 3rd power. That's exactly the same thing. 2 to the 3rd power is exactly the same as 8. Now is it easier to see that this right here is definitely the difference of two cubes?
Yeah.
Okay, so in this case, no matter whatever answer ends up with, it's going to have that 2x squared out in the front because it's waiting out there for it. It's outside the club waiting for its friends. All right. 2x squared, let's break the gray part there down into a binomial and a trinomial. Which symbols am I going to use there? Which signs?
It's gonna be
A minus,
and then
a plus, and then always a plus. So, same sign. Same sign as this. Opposite sign, always a plus.
Why is that the second one a plus and not a minus?
Because remember with soap, it stands like this. It's the same sign for the first one, which is same sign. Then the second one is the opposite sign. So the opposite of minus becomes plus. And then the last one is always a plus. All right. Faith, talk to me about what my A and what my B are.
So A is x and B is 2.
Beautiful. Keep going.
And then
So here, I'll write this out. This one is A. That's going to be B. This is A squared. This is B squared. And this middle one is A times B.
leave for x minus 2. And then x squared. And then I think it's 2x. And then 4.
Beautiful. Couldn't have done it better myself. That's exactly what this should look like. That is the factored form of all of this. Yes, ma'am?
But you have the other
That is all the factoring that we're going to learn in this lesson. Yes, sir.
B is 2.
Because the number that is being cubed to make 8 is 2. 2 times 2 times 2. That's why it's not 8. It's like A is not x cubed. The thing that is being cubed is x, right? X.
It's not -2.
Because we're only going to look at the 8. Like, so you're right that it's a -8, but we're just looking at the number that's right there. And to get that 8, I would need 2 cubed. Okay, you have all the skills now to do everything in the homework. The hardest part is recognizing them. That's what we started with there. Is how do I recognize what problem this is? Like, if I look at D and I don't tell you what to do, you might have to try some things. Pull out a common factor. I would always do this. If there's a common factor, always pull it out in the beginning. See where that takes you. Because that is going to be a very easy way to get through things. If you can pull something out, pull it out. Because you'll probably see it as soon as you pull out the GCF. All right, we've only got about, what time we get? 10:05? So we've got about 12 minutes. But use this time to finish up your homework. Remember, it's due Monday. Why not get it done before the weekend?